All right, hello everyone. Today we'll be looking at current electricity. Now, last time we looked at static electricity, we know that those are charges, stationary charges that build up on the surface of a material. Now, what is current electricity? Current, what comes to mind when you hear the word current? The first thing that comes to my mind is a river and water moving. So it is along that line that we look at electricity now as the flow of charges. No longer are they stationary or static, they are now flowing. So current electricity, definition we could write. So this is a broad topic. We can narrow it down to electric current. What is electric current? We say electric current, electric current is the flow of charge through an area per unit time, or we can say per second. Per second. In terms of a formula, because we normally use formulas, we have to do a definition. Some persons prefer to remember the formula, and in remembering the formula, they can derive their definition. So let's write the formula for this. I stands for current. So for the word current, if you don't want to write out the word current, you can write I. So I'll first write it in words. Let's do that first. Current is equal to charge, and this is a charge flowing through a particular area per second. So down here we're going to put time. Now, in terms of symbols, to represent the word current, we use I. To represent the word charge, we use Q. Q to represent a big charge. Now, to represent time, we use T, comma T. Now, this Q can be capitalized, or you can use the common version, which just means a small charge. So, we have another formula that we'll be using more than this one. So let me know write that. Also, and you'll see why we're using this. We're going to use this formula more often. So we start with this general formula. Voltage equal to current times resistance. And current equal to voltage divided by resistance. Now this is the same formula transposed. So we want I to be the subject of the formula. So we divide both sides by resistance. It is cancelled over here, and now we have that I is equal to voltage over current. Sorry, I is equal to voltage over resistance. Yeah. Now this formula will be used more often because at this level, so we're at the grade 9 level here, we won't be looking at so much charges moving through an area over time, but more so how voltage, current, and resistance relate to each other. Now it's time for us to define what voltage is, what resistance is. We already defined what current is. So let us do that. Voltage first. All right. We write or voltage, that this is the pressure provided by a power source. The pressure provided by a power source. The force, the pushing force provided by a power source. To push what? To push the electrons around the circuit. To push the electrons around the circuit. So the greater the voltage, the greater its ability to push electrons. These are the charges we are focusing on. The electrons around the circuit and thus produce current. Now, what are some types of power sources? We have batteries. Let me get a battery for you. Here we have some batteries. Everybody should know these batteries. They are somewhat universal. All right, so let's write that now. That this is the pressure, this is pressure, this is the pressure provided by force source for example, a battery, to push electrons around a circuit. Voltage is measured in volts. Voltage is measured in volts. So therefore, the rating of a battery is in terms of volts. So these batteries, I believe they are 1.5 volts. 1.5 volts, but they last very long because they have a greater capacity than the small 1.5 volts. But you have batteries that come in 9 volts, 12 volts. All right? That simply means that the greater the voltage, the greater its pushing pressure, its ability to push electrons around a circuit. Now, voltage is equal to current times resistance. Now, if the resistance is great, the voltage needs to be greater to push the electrons against that resistance. Now, the greater the voltage, the greater the current you can get. If the resistance remains the same, if you increase the voltage, you get more current. Let's look at resistance, because we've been talking about voltage and how the voltage needs to be greater than the resistance or increase as resistance increases if we want the current to remain the same, or if we want more current, we keep the resistance at a certain level. Let's see, what is resistance? To resist, if you're resisting something, what are you doing? What are you doing? What does it mean to resist? Can mean to prevent, to hinder, to stop. And if you said any of those, you are very close, you are correct. So resistance, this is a measure. This is a measure of how much a material impedes or hinders the flow of current. And we could put in bracket the flow of electrons. Now you have certain materials that they are structured in such a way that when electrons see through them, the electrons are bombarded by other particles, right? And this in turn decreases the amount of current you would have moving through, for example, a wire. Now, resistance is measured in ohms. Resistance is measured in ohms. OHM. And Greek symbol, the Greek letter omega, is used to represent that. Now, let us write the formula for resistance. So, resistance would be equal to voltage, right, divided by current. That is what resistance is equal to. And you're probably saying right now, sir, how would we use this? When would we use this? You would use this formula if you are given a question to find resistance, and they give you the voltage of the power source, and they give you the current flowing through a part of the circuit or the entire circuit. So once you have voltage and current, you can do resistance. Now let's recap. We're going to recap real quickly, and then we're going to do a question. We need to do a question, at least one question. So current between brackets I, that's a symbol, the word current. SI unit, amperes, A, voltage, we use backward V, SI unit, volts, and we have resistance, R, SI unit, ohm, OH, and the symbol for the unit is omega, it's Greek letter. So I don't want you to confuse now the symbol for the quantity and the symbol for the unit of the quantity. So the unit for current is ampere, and it is capital A for its symbol. The unit for resistance is ohm, and its symbol is omega. If you don't want to write the word resistance, you can write capital R, sometimes a common R, depending on what you're doing. Now, let's look at a question, and you can do this also in your book, so you can pause the video and do it in your book. So the question says, calculate the current through a circuit if the resistance in the wire is 6 ohms and the battery has a voltage of 3 volts. So they want us to calculate resistance. We don't know resistance, so I put a question mark. The resistance, current. I want us to calculate the current. Current here, no? Resistance is equal to 6 ohms. Voltage is equal to 3 volts. Now, what is the formula for current? I typically start with this formula. Voltage is equal to current times resistance. And from here, we can find any of the two. So this is already in terms of finding voltage, but we can find current or resistance. In this case, we need to find current. So let's go. Current, therefore, will be equal to voltage over resistance. Now, let us see. What's a voltage? 3 volts. Resistance, 6 volts. Now, 3 divided by 6 will give us 0.5. The unit, not I, but A for amperes. 0.5 amperes. Question easily done. Let's move on to our next one. The second one is very easy. Calculate the voltage of a battery if the current through the circuit is 3 amperes and the wire's resistance is 4 ohms. Let's go. We know our formula. We normally start with V is equal to I times R. Do we need to make any changes? No, we don't need to make any changes. It is already in terms of voltage. That's the subject of our formula. We need to now put the values that we have for current. It gave us 3 amperes times 4 ohms. And when we multiply the numbers, we get 3 times 4 is 12. And what would be the unit for voltage? We get 12 volts. And we write 1V. Easily done. If you got that right, you can go ahead and plot yourself. We move on yet to another one. This will be our last question on this aspect of current electricity. Now, in this question, I'm going to draw a diagram. So this is number 3. Let's draw a diagram. Marker isn't working. This is a circuit diagram. All right, let's put some values in. This right here is a resistor, a fixed resistor. Let's put resistor, resistor. So this is the symbol for a resistor when you're drawing a circuit. So it's more of a rectangle. It's more of a rectangle. So ensure that you use your ruler to draw this. So you get a better straight edge. Alright, so that looks a bit better now. So this is the symbol for a resistor in a circuit. Now we have here a symbol for a bulb in a circuit. Up here we have a battery. So the battery is our power source. This is the symbol for a battery. Now this is the value for a resistance. It's 12 ohms here. Our battery is 7.2 volts. Yes. Now you see these arrows here going around. These arrows represent the current flowing through our wires. So these are our wires in our circuit. And the current is flowing from the positive terminal of the battery to the negative terminal. Now this is what we call conventional current. So this is the convention for current to flow from the positive terminal to the negative terminal. As you move up, we will delve deeper into conventional current and electron flow. But for now, we are going to find the current flowing through this circuit and also through the bulb. Now, don't let this scare you. It's the same thing. We use the same formula. We have resistance and we have voltage. That means we can find the third one. And we start with the formula current. Voltage is equal to current times resistance. Now in transposing, what would current be equal to? We get that current is equal to voltage divided by resistance. Let's put that over here. Current is equal to voltage divided by resistance. What's the value for the voltage? 7.2 volts. Value for the resistance? 12 ohms. 7.2 divided by 12. We are going to get 0.6 amperes. And that's all you need to do. That's all you need to do. So thank you again for watching this video. I hope it really helped you, whether you just want to know or hear it for yourself.